Za'abeel is off the charts.
The second biggest statement after Burj Khalifa, inshallah.
This is one of the most complicated structures.
It's been a great challenge.
We're showing the world that Dubai can stand out above the rest.
I can guarantee this is engineering heaven.
Dubai's latest icon. Built on an architectural vision that demanded unprecedented engineering skills. Dreaming big is essential to building the impossible. Welcome to Za'abeel.
Being in Dubai gives us the opportunity to build significant landmarks in not only regional terms, but in world terms.
Za'abeel is the latest addition to the city's ambitious construction efforts. The gravity-defying link bridge is reshaping Dubai's skyline and demanded a complex construction process of significant scale. Experts from all around the world have teamed up to take on this once-in-a-lifetime challenge.
What makes this job unique is it's not just two towers. It gets linked with a 250 meters of link bridge that weighs 8,500 tons.
This project is unique in the world.
We're exceptionally proud to be part of this.
Located in the heart of the city, connecting old and new Dubai, the chosen plot for Za'abeel comes with numerous challenges. The storage and the space for construction material laydown is very limited. The access to the construction is extremely difficult because the site is surrounded by roads and a 4-lane highway spanning between the towers, over the podium and under the link.
You can't stop vehicles, you can't do this. There's so many things that influence our logistics on site.
Reaching 42 meters below ground, the basements will feature parking lots and support service areas. 2 underground tunnels are connecting the towers. The mixed-use development includes luxury residences, offices, and hospitality spaces. A logistical feat, which starts with a record-breaking concrete pour of 26,000 cubic meters over a 7,600 square meters raft foundation. The ongoing construction in the area posed a significant risk to the large traffic bridge.
A very important aspect was to keep monitoring of this live highway that was running through Za'abeel. The bridge monitoring was done by sensors placed on the bridge itself, and that was controlled and monitored from a center database. We always needed to make sure nothing interrupts the main traffic flow of this bridge. Keep it live, keep it uninterrupted. From this, you can actually see how very close the RTA bridge was, going into a range of approximately 5 meters away from both buildings.
It is the start of a monumental construction encompassing a total build-up area of 530,000 square meters. At its heart, the link, an iconic world record-breaking 230-meter sky concourse. To erect this massive structure, the team will undertake the heaviest commercial lift ever attempted. The link will connect both towers 100 meters above ground. Its construction on site starts with the assembly of 7 large steel modules and a temporary launching nose. Each module weighs up to 1,742 metric tons and measures up to 51 meters in length. The nodes and joints are prefabricated off-site to save space and welding time.
The yellow identified steel structure is temporary works and it's got a dual function. The first function is to assemble this 8,500 link bridge, and then it's to use it as a sliding platform for 6 slides to slide across the Al Sada highway.
There's a significant force required in order to move it. So we used what we call horizontal strain jacking. So strain jacking typically is always used in the vertical plane, so it's used to lift things, but we came up with a series of levers that allowed us to do it horizontally.
This is our sliding equipment that consists of the pump and the jacks. The pump is pressurizing oil and the jacks are pushing the shoe, which subsequently pushes the whole link bridge further down the rail. So once the control room confirms that everything is in place, they push the button, the pump starts pumping and the link bridge slides.
The first slide is to ensure that the system functions correctly. After analysing all data and making sure that the sliding friction is matching with the engineer's calculation, the first segment with the launching nose is pushed 18 metres along the temporary platform, to the edge of the podium and over the bridge. Every slide creates space to assemble the next segment. With each new segment welded to the link, its weight increases, reaching the most critical stage, the final sliding process, which means crossing the road with more than 7,100 tons of steel. The slides are only possible at night. Dubai authorities need to close the road below the link. The quietness is also an advantage for the engineers who are listening constantly to any sounds coming from the bridge and the sliding process.
As a last slide, it requires very precise alignment for the lift-off, and dealing with such colossal structure in so small measurement is very hard.
With this 40-metre slide, the team achieved a significant milestone. The final task is to remove the temporary shoes before lifting this massive structure into the air.
The structure, what we're lifting, is about in the range of 8,500 tons. The length of the structure is about 195 meters long. So this will be lifted during the stage 1.
Lifting this weight up to 100 meters above ground, that is the heaviest commercial lift ever done. A colossal task for the engineers.
So today we push the button and start introducing force into the link bridge through the strands. Using the towers themselves to lift, it means we have to be very careful.
As the towers take on the immense weight of the link bridge, they start rotating and deforming. A physical challenge that the ALEC team factored in beforehand.
We've built 2 towers. Both of them are leaning out so that when we lift the link bridge, the 2 towers will then come back to the vertical position.
A mere 100 millimeters. That's the distance of the first lift operation. A small distance including big risks and absolutely no room for mistakes.
Okay, come with me. This is a control. I'll show you. So in this system, we have monitoring of the tower behavior, which is basically recording the tower displacement minute to minute. We have to make sure that is behaving as we calculated.
The second lift of the 195-meter-long link bridge is up next, with just 1 additional meter to go.
The reason we're lifting it is because we need to get some space below the sliding shoes that we've cut off, so that we can get working space underneath and do the repairs.
The third and final lift operation shows whether the practice lives up to the theory.
We started at 7 o'clock this morning, and we're going to be progressing at approximately 5 meters per hour. We will be stopping every 10 meters to grease the cables, and then we'll commence again. But if all goes well, we'll be up in position by the weekend.
After 3 days of lifting, the link bridge reaches its final position 100 meters above the ground. The new landmark begins to take shape, offering a glimpse of its design as it nears completion, with one integral component still remaining. Ready to secure the link in its final position, the team will spend 6 weeks welding 142 points to the tower before proceeding with the lift of the cantilever. To finalize the shape of the link, the second segment, called the cantilever, is ready to be lifted.
After the huge success that the first lift was, we've now completed the assembly H, which is the final 33-metre cantilever portion of the link. It weighs about 950 tonnes, and we're going to be lifting it 103 metres into the air today.
The cantilever, like the towers, is built with a slight camber.
The tip of cantilever is 300 millimeter pre-cambered upwards, and that's due to the loads that will come after construction of the steel structure. So once we add all the loads, like facade, concrete slabs, swimming pool, and all the other features that goes onto the bridge, that point is going to deflect 300 millimeters down, which will be near to zero or to horizontal position.
Lifting the cantilever at a rate of 5 meters per hour. The process takes 3 days to complete.
Many people actually stopped on the street with their cars to see how is this progressing and what's going on. They didn't expect, when we finished the assembly, that we're actually going to lift this 125 meter in the air.
The link reached now its final length of 230 meters of steel structure, a world record for the longest cantilevered building.
People will start to really see what a magnificent structure this is.
The link is in place and the towers are constantly rising. Simultaneously, the engineers are starting the MEP work.
We look after the electrical, mechanical and plumbing of the building, from design all the way through to final fix.
One of the big challenges of a high-rise building is moving both men and materials into the building.
Space is very limited and the site is congested, leaving little room for trial and errors. Through off-site fabrication, the engineers can improve installation time, enhance accuracy, and reduce risks on site.
We build the frames at our plant yard facility, and then we shift them to the project and we lift them up from there.
Alemco decided to use 3D technology in forms of BIM, Revit, Autodesk. The need for that arose due to the complex designs that we had to face. 3D has enabled us to reduce clashes on site, improve our installation quality.
More than 100 modules need to be installed, only in the link bridge.
We are very lucky in terms that we have a 3D models that we can actually look at on site. We can walk through the areas, you can see any potential issues, clashes, and you can work it out on site to come up with rectifications.
Hosting various exclusive restaurants, the link requires an elaborate MEP system for the kitchens.
The kitchen ventilation ducting is massive. It's a big extract system. You have hoods that you have to condense, so you have a coordination with other contractors at the same time.
Outside, the facade is starting to shine. The tower shifts depending on the angle, with glass fins and white dots that enhance shading and depth. The podium features a flowing design with colourful aluminium louvers concealing functional elements, and the entrance roof is inspired by desert dunes. On top of the link, the engineers are facing the next challenge. They are constructing one of the longest suspended infinity pools in the world.
The pool is made of acrylic flooring, and those acrylic floorings were come into small pieces, and we had to actually lift them and install them in the pool area.
Next crucial step is to fill the pool with water.
There is a total volume of 640 cubic meters of water. Having it with no leaks and within the limits of the structural limits is one of the milestones in this project.
When we fill the swimming pool, that load basically is going to cause the building to rotate and deform.
All these movements were calculated up front to make this unparalleled view possible. MEP work provides the essential requirements of a building, making it livable and ensuring an outstanding stay for everyone who will visit One Za'abeel. While MEP work is nearing completion, the fit-out of the residential area, the hotel rooms, the restaurants, lobbies and the pool site is in full swing. Sales for residential units have already started. Mock-up apartments are ready for viewing. Each area at One Za'abeel has unique fit-out requirements. For the luxury hotel, the team must ensure exceptional quality to create an unforgettable guest experience.
For me, the most challenging part was the coordination between the different trades, especially electrical and ELV with the fit-out, because there's quite a lot of joinery items in the room. And yes, it was a bit challenging, but we managed to pull it out, and here is the result.
To consistently meet clients' demands, ALEC is implementing state-of-the-art solutions. One example is Myro, a painting robot that works quickly and without any breaks.
We see the future of this. We see it painting ceilings, we see it doing more difficult works, and that's where what we're aiming for. We want our people to be envision and understand what the future looks like, and to start to incorporate these kind of tools within their project.
Augmented and virtual reality applications are transforming the construction industry. For a contractor, the goal is always to deliver projects on time, within budget, and to clients' expectations.
ALEC has decided a few years ago to make innovation as one of our core values, which means that everybody in the company is expected to think out of the box, find new ways of doing things better and more innovatively. So we are very much part of the innovation journey in the industry.
After many years of hard work, the new icon opens its doors in March 2024. The Link is now a floating boulevard, home to ultimate luxury. Its offerings include 5 Michelin-inspired restaurants by celebrity chefs, a chic destination bar, the UAE's longest suspended infinity pool, and unobstructed panoramic views of Dubai.
There's always an inherent risk when you're doing something for the first time. So you're always nervous, but when you pull it off, you're not only relieved, you're immensely proud as well. The individuals that built the job, we knew they were good before, but at the end of this job, their ability and their tenacity is going to set them apart.